talked about how vertex form is nice because it lets us do everything. It lets us graph it. It lets us state all its properties, like the vertex, the equation of the axis of symmetry, the maximum or minimum value and where it is, the domain, the range. When it's in standard form, we can't obviously see all those properties, only a couple, okay? However, there is a way that we can calculate the vertex if it's in standard form. Now, what I'm about to do here, first, step one, remain calm, because I'm going to be doing some algebra, and it's going to look a little complicated. But if you can follow, try and follow along as best you can. Are you going to be asked to do this on your own? No. But I do want to show you where it comes from rather than just giving you formulas. Okay? So I want to take this vertex one and I want to change it to standard form. I want to make it look like this. Okay, so first of all, I'm just going to change this to y, make life a little easier on myself. Okay, now, first thing I'm going to do is I'm going to multiply these two. Remember, x minus h squared means x minus h times x minus h. So all I've done is I've written out the x minus h all squared. Next thing I'm going to do is I'm going to actually multiply these two up. 4 multiplications. So I'm going to get a times x squared minus xh minus xh plus h squared close parentheses plus k. And I can simplify inside the parentheses a little bit. Minus 1xh and another minus 1xh make minus 2xh. Now, and remember what h and k represent. Those represent the vertex, right? Okay, so now we're going to multiply through by 8 to get rid of this parenthesis. So ax squared minus 2 axh plus ah squared plus k. And the only other thing I'm going to do after this is I'm just going to rearrange this so the x. Remember, multiplication, the order doesn't matter. I'm just going to rearrange this so the x at the end. So 2ah. That's all I've done. Believe it or not, that's standard form. Because, remember, it's x squared, x, and then some constant, right? Well, here's x squared. So here's a. Here's b. Here's c. That's standard form. It just looks very complicated. Okay? I'm going to focus on this one. So if when it's in standard form, the value of A is equal to the value of A, the value of B is equal to -2 times A times whatever the X vertex is. Because remember, this is the X vertex. This is the Y vertex. So I'm going to focus on this. So B is equal to -2A H. Can't I solve for H? How do I get H by itself in this equation? How do I get rid of times -2A? Divide by -2A. Divide by -2A. So therefore, to find H, I'm going to do negative whatever the value of B is divided by 2 times whatever the value of A is. Isn't H the X vertex? This is how you find the X vertex when it's in standard form. You take the value of B, whatever's in front of the X, the value of A, whatever's in front of the X squared, and you go negative B, divide 2 times A. How do you figure out the Y vertex? Well, once you've got the X, just plug it back into the function and calculate Y. So the Y vertex is when you take the X vertex plug it back in and calculate it. This will make more sense when we do an example, because it looks pretty crazy now with all the letters. Okay. Just remember this. So to find the X coordinate of a vertex in standard form, Y equals AX squared plus BX plus C. We use the formula, the X vertex is equal to negative whatever the value of B is divided by 2A. To find the Y coordinate of the vertex, we plug XV back into the standard form equation. And solve for Y. The vertex is key. Yes.
The formula for X for X make it plus or
Yeah. Yeah. So let's, before we jump to the next page, that example, let's just do one at the bottom here. So what if I said, if I gave you this, Y equals 5x squared plus 20x minus 1. And I asked you to find the vertex. Well, before today, you guys would find the vertex by completing the square, right? You'd have to complete the square, get it into vertex form, read the vertex, and then you can get everything else from that. You don't have to do that anymore. What we can do is we use this formula to find the X vertex. So remember, In this, what's the value of A? 5. What's the value of B? What's the value of C? -1. So to find the x vertex, I do negative, whatever the value of B is, 20, divided by 2 times the value of A, which is 10. -20 divided 10, x vertex is -2. And now that I know the x, plug it back in to the original standard form function and figure out y. Remember your order of operations. -2 all squared is +4 times 5 is 20. 20 times -2 is -40, so plus -40 is just the same as -40. -1. So 20 subtract 40 is -20. -20 subtract 1 is -21. There's your vertex. -2, comma, -21. Some would probably find that easier than completing the square. Unless it's a pretty easy completing the square question. If there's no number in front, then maybe completing the square is quicker. But this way, you don't have to complete the square. And actually, after this, I'm not going to worry so much about completing the square, but I did want you to know how to do it. Okay? So on the test, I'm going to ask you to complete the square on something. But after that, we're going to really focus on using this instead, because it's a little bit more efficient. Okay, so first example. So we've got a function in standard form. I want to know a bunch of properties. Vertex, domain and range, equation of axis of symmetry, max or min value, y-intercept. Well, to find like domain, actually all of these come from the vertex. I can find the domain without the vertex. It's everything. I can find the y-intercept without the vertex. I just plug 0. But all of these other things come from the vertex. Okay? So the vertex is really important. So what's the value of A here? What's the value of B? -12. C, I don't even have to worry about because I don't use it in. Okay, so let's find the x vertex. -b over 2a. That means -12 over 2 times 3. Which works out to what? Yep. 2. Take that 2 and plug it back in for x to figure out the y vertex. 3 times 2 squared minus 12 times 2 plus 5. And then calculate. Remember, squaring before multiplying. 2 squared is 4. 4 times 3 is 12. Minus 24 plus 5. Looks like it gives me -7. Okay, let's go. Properties. Well, vertex, we just found it. Domain? Negative infinity to positive infinity. Don't need the vertex for that. The range, however, I need the vertex. Because it's the lowest y value to the highest. So first of all, I need to know whether it opens up or down. Because it's positive in front, right? So it opens up. So that means that the vertex is at 2, -7 up forever. So the range would be from -7 to infinity. Because -7 is the lowest y value, and then it goes up forever. The axis of symmetry equation is x equals 2. That's the vertical line that cuts the parabola in half, makes it symmetrical. Does it have a max or min? The vertex tells me. Has a min at where? Y equals -7. Notice that the min and the range are kind of connected. Well, actually, they are connected, not kind of. And finally, the y-intercept. I think that's everything I was asked, was it? Well, now you got to go back to the function and plug 0 in every time you see an x. So 3 times 0 squared minus 12 times 0 plus 5. Well, these just become 0. So my y-intercept is just 5. Okay. So not only could you state all the properties, you could actually graph it too. Okay, so we could have gone one step further and graphed it as well. Okay. But I